everyone, I'm Kathy, Western specialist from GenScript, and we are the world's biotech company with GenScript, protein antibody and preclinical drug development service capabilities. So in this webinar today, our catalog product manager, Dr. John Lee, is going to introduce you the streamlined Western blot workflow incorporated with GenScript instruments, which include eBlock, eStand, and EasyOS, and the benefits that they will bring to your experiments. So this webinar will take around 5 minutes, and it will be a recorded session. You can type in your questions in the chat box, and we'll answer them after the presentation. If you didn't get to answer your questions during the Q&A session, we'll be sure to take them and I will email back to you. So without further ado, let's welcome Dr. John to start his presentation. Dr. John, over to you right now.
Thank you. Can you hear me clearly?
You can start the presentation right now.
Okay, I can start the presentation. All right. So today we'll talk about what we did for protein analysis, as it's a very common technique we used in laboratories to research, regulations of different processes. Hello? Can you hear me? Okay, well, I'll continue. Well, there are many different techniques when we are studying proteins, and here list some of the very common ones. And we're trying to, as in our model, make it easy, make research easier. Now, one of the central topic here today will be Western blot, where it's a very staple method in many labs. I think you might have used it in your research as well. Now, as we go through our research, the requirement changes with the time. When times are changing, it just seems like this method doesn't change with it. And so let's look at what we are required to do now. Take an example. This is basically a chart from a Cell paper in 2000. And around that time, the Western results are relatively simple. You can take one different fractionation and then look at different fractions, look for your target, and that could make up a very good publication. Well, when we look at 2020, when we look at another a typical Western result in a regulation study, you see there are many different targets, there are mutations, and each one of these Western markers are quantitated, and then they have the error bars. And so that entails two things. One, there's a lot more experiment that needs to be done, and that translates to a lot more time. Now, if we do this with a typical Western workflow, and as you can see, it contains many different steps, and that would take many days to finish your research. The question we ask is there any way for us to make this process a bit faster, a bit more convenient for our researchers? Now, if we simplify this with this process into different steps, we can take it from the sample preparation and then use the SDS page to separate different protein targets, and then transfer these targets onto a membrane, either it's a nitrocellulose or PVDF, and then we show the signal with incubation with different antibodies. And after that, we take our image and quantize it, and then get our results. The whole process can be a very long day if we follow the very conventional protocol. For SDS page, if you make your own gels, and it'll take about an hour and then a couple hours to run the gels, and it'll take about 2 hours to do a wet transfer, and then the very involved steps of different incubations will take about roughly 5 hours. So if you put every hour together, you get about 10 hours. That's when you get your samples ready before you get any results. And that's a very long day if you want to finish your research in one day. Now, the one thing we want to attack first is, of course, the most complicated part where all the incubations are done. And because they involve many different steps, and then many steps have to be repeated multiple times, like washing usually have to be done at least 3 times each time. Between you switch between antibodies or between the blocking to a primary antibody. So that's why we worked on this little device called EasyOS Lite. As the name entails, we are trying to make the whole incubation process easier, okay? So many of you might not have ever heard of this because it's a new release. It's a new device we just released to the market. And so here is an enlarged picture of it. It's a relatively small and can fit on any bench top, and it's relatively easy to use, and which I'll show you in the coming slides. And here lists some of the key attributes for EasyOS Lite. So the goal of this device is to fully automate the incubation steps. That's starting from the blocking all the way to the secondary antibody incubation. And we're hoping that by removing any manual process, we can provide a more consistent results. And we also designed in this device to be able to recover both primary and secondary antibody, so you could reuse it, because sometimes especially for primary antibodies, it can be hard to get, and you want to use it as much as you can tolerate. We also made this programmable, which give it flexibility, where you can match it to your conventional protocol. Although typically you can reduce your incubation time on this device, but you can start from your standard protocol and use it for your first experiment. And the last but not the least is it's an open platform. We don't tie it to any consumables, and you can use consumables existing in your lab. So here is just some more detailed numbers. So this device will take one set of antibodies, meaning one primary antibody and one secondary antibody. But it can process 2 membranes at the same time. You place both of them in the cassette, and then you can process them at the same time. You can use strips. Sometimes you want to cut your membrane into smaller strips, and that's okay too. So for the device, it fits mini gels. So if you use mini gels, we're looking into mini cassette, which is coming soon, but right now it fits mini gels only. For antibody volumes for primary and secondary, you need about 9 mils of diluted antibody, and then you can recover them, of course. And so this is just a little bit more details on it, and then now let's look at how it all goes together. Now you have a device. When you get the device, you also get a cassette, which is on the right-hand side. It can be opened up with the lever on top, and once you open up, you can put your membranes in there. So for your experiment, it's actually quite simple and easy to do. The first thing, of course, is to load your blocking buffer and antibody solutions into the system. And then we use the 50 ml standard 50 ml centrifuge tubes, and you can put them in the corresponding slot on the side of the device. And once you've done that, it's time to load your membrane. And so you open up your cassette, and it's marked on where the membrane should go, and where the high molecular weight and low molecular weight should orientate. And the protein side is always facing up, and then you put a spacer, where the spacer is to keep the membrane from floating around in the cassette when we are doing the incubation, because the device actually is actively circulating the solution to make sure that we get a good incubation of antibodies. So once you get everything set, you load your cassette onto the device, you program your experiment, and you say start and walk away. And the membrane will be ready when you come back. And so that's what we are trying to do here, is to make it easier. Some results we have when we have compared the EasyOS Lite with the conventional protocol. One is using the housekeeping protein, a GAP-DH. As you can see, it's a very comparable results. Same goes for EGFR, a different target, and or VDAC1. This one is a little bit lighter because of the abundance of the protein is relatively lower. And so this is what we've done in our labs. We also have done some tests in our, fellow researchers lab. Okay, this is one of the example, and using GenScript's anti-His HRP antibody, which is a primary antibody directly connected to HRP. So as you can see, if you look at both the manual protocol results from the left and compared to the EasyOS, the results from the right, they both showed up nicely, and then just seems like EasyOS Lite can produce a little bit of more sensitivity. But in reality, most cases what you'll have is the comparable results to the manual protocol. So now, just to summarize the EasyOS Lite part, so this device is designed to automate all the incubation steps for Western blotting, and that's a lot of the hands-on and sometimes kind of boring. So we want to free you from that process, so you can hit start and you can walk away and do whatever else you think is more better for a time. So the design of the device is easy to use, and it's actively circulating the solutions for either blocking or antibodies during the incubation to make sure we get the best of the results. And by removing the manual operation, we're hoping to achieve better consistency, which we show in our test results. And more importantly, it's an open platform. We're not locking out any of the reagents that you're currently using. You can still use them. Although after your first test, you might need to tweak a little bit just for a better results. If it's too strong a band, maybe you want to reduce your antibody concentration a bit more, things like that. So we don't try to attach any mandatory proprietary consumables to it. So the device itself is really very, very small, and you can fit it anywhere in your lab. Okay, and so at the last point, a bit of a pre-announcement is that we are actually, researching EasyOS diluent. So this diluent is a reagent used to dilute your antibodies, and the goal of this diluent is twofold. The first is we wanted this diluent to be able to reduce the amount of blocking you need. So it'll be replacing the milk or BSA that you typically use for blocking, and also be able to reduce the blocking to just a few minutes. And then the second goal is to, for this diluent, is that it will be able to enhance the signal or reduce the incubation time. So we plan to have half the incubation time. So if typically you incubate for 1 hour, and with this diluent, you'll be able to cut that in half. And so this is at the very final stage of the research, and we're almost ready to release it into the market. And so with the EasyOS device, you can reduce the incubation time and then to about 2 hours. Now the whole Western process are cut down to about 7 hours. It's still a full day work, but it's much better. So fortunately, we already have other things in our repertoire to be able to further shorten this time to a more manageable degree, and one of which is a transfer device. And as you know, that for many, there are many different type of transfer method. Two of them are most commonly used, which is the wet transfer, or what we call conventional wet transfer. And it's a golden standard in terms of the methodology. And the downside of this is the setup is relatively complicated, and you need a lot of buffer, you need some ice and or a cold room to be able to set it up. And it also takes quite a while to run the experiment, usually at least 2 hours and sometimes overnight. But it'll give you good results. Now, there's also some device on the market where you can get with the semi-dry method, and it uses a lot less buffer and a lot less messy when you set it up. You can do the transfer, finish it very quickly. But the downside is whenever you have a protein that's just a tiny bit larger than it likes, it won't transfer very well. And so that kind of bothers a lot of researchers, me as one of them when I was working in the lab. So the question we ask is whether we can actually combine the two. So we can have some device that can transfer fast, but just as the wet transfer where we can get good results. So that's where the EBlock L1 is take the role. And so this is the only device that uses the wet transfer principle in a fast transfer device. And you won't find anything else. All the other devices, either it's a wet transfer, a slow wet transfer, or it's a fast semi-dry. So with EBlock L1, you'll be able to get the best of the both worlds, and you will be able to get good results when transferring large proteins, and that's generally something that's larger than 100 kD. Or you can also get short transfer time, usually somewhere around 12 minutes. So just to show some comparisons between the wet transfer and the EBlock and the unique fast wet transfer. And as you can see from our test data, that the transfer can be very comparable from EBlock L1 to the wet transfer that you typically use. Here are just some more comparison, not just to the wet transfer, but also to some other devices on the market. As you can see, while there's less of a difference with smaller protein, when you get to a larger protein like EGF, you see a lot more pronounced difference. Now here we also have a story to tell from our research team, as this is a bit of an unusual case. It's just a story, and it's not a typical application per se, but it just shows how well the wet transfer works with EBlock L1. So we have this customer in America where he's working on some massive complexes, and it's a large protein with multiple components, and he wanted to do a Western to basically characterize it. And he's tried basically everything before they found us. This protein is about 1200 kD, which is usually not something that people typically work on. That's out of the range. And he's tried wet transfer. He's tried semi-dry, all different kind of semi-dry devices, and he wasn't able to get satisfying results. And eventually, one day, he saw one of our flyers about the EBlock L1. So he contacted us, and he wanted to try it. I would say, well, we have not got a chance to try a protein complex that large, we might as well do it. So we worked with him. It didn't work that great at the beginning, but once we tweaked the protocol a little bit and we added some extra optimization into the protocol, we were able to actually get a very good results with this large complexes, which surprised us as well because we didn't know it could work that well. So yeah, just a story to show that there is also room to work with even larger complexes than the typical range of from 20 kD to maybe 200 kD. Now with the wet transfer, the EBlock L1, we were able to reduce our transfer time from 2 hours to about 10% of that is about say 20 minutes. Let's include the setup time, and of course we can also reduce the time from the SDS page for sure, to further downsize the 5 hour that we have to spend working on the bench. And with that, you can take a look at our offering of precast mini gels, and these are specially designed gels, and that's with a neutral buffer system. So it's very stable, and it has some good designs. If you look at the lower right-hand corner, you'll see the GenScript design for the loading wells is a little bit different from what you would typically see in the precast gel. So it has a notch at the very top of the gel before the loading well, and that enlarges the loading capacity of the gel to a much larger sample volume. So it can go all the way up to about 80 microliters. So if you have samples that's low concentration, this will come in handy. And we also offer very complete concentrations for fixed percentage gels or gradient gels as well. So one of the features we designed into these gels is that they can be run at a very high voltage. It's 200 volts. And at this voltage, you can finish the gel if you use a mass buffer system within 20 minutes. So 18 is, the limit usually. And if you use the MOPS buffer system for larger protein separation, then usually it's around 30 minutes. And that's a lot faster than the hand cast gels in a typical lab. This is just a comparison in case that you're wondering why there's two buffer system. We have the MOPS and then also the MES or MES buffer system. They both work for Nutrigels equally well. It's just that their focused area of separation is slightly different. For MOPS, it's designed to separate medium to large proteins, usually above 30 kDa. And as you can see on the left-hand side gel, the larger protein gets separated a lot better, and then while the smaller protein get compressed together. On the other hand, if you use the MES buffer system, you get much better separation for smaller proteins, and a little bit less separation on the top of the gel. Well, for Western blotting, it's usually not a big deal because we are doing something that's specific to certain targets, so either would be able to work for Western blot. Here's some comparisons in terms of resolution as we enlarge on the section of the gels running.
Hello.
Is there yes,
Hello, Dr. John?
Cassie? Yes.
Yeah, we can't see your screen right now. It's missing. Could you share it again?
Oh, really? Let me try to share it again. I'm sorry. Let me see. There must be some internet connection issues. Just give me a second.
Can. No problem. Okay. I think we lost it like 5 minutes ago.
Oh, really? Okay.
Yes.
Okay, sorry about that. Let's see. I guess we can share the slide. Okay, now it's sharing again. Let me know if you see it.
Yes, I can see your screen right now.
Oh, that's great. Okay, should I continue? Right? Okay, let me do that.
Yeah.
We can also share, I guess we can also share the slides, with a link and just so that we have the full information. Okay, thank you.
No problem.
All right, let's continue here. All right, so where we are. Okay, MES buffer. It's better for smaller proteins, but both works well for Western blot because it's a very specific methodology. Now, this is just a comparison of the separation resolution. If we enlarge on the gels on the section, these are just lysate loaded equal amount onto each of gels. And as you can see on the short page, which is the GenScript gels, you can have very good separations within this range. So some homemade gels, which is the third to the left, and it gets blurry, and especially this will be more pronounced if the gel has been stored for a while. The separation will not be as sharp. Okay, and there's also other precast gels, and as you can see, the resolution, is not as comparable, especially from the second to the left gels. There's some missing bands in the middle, and so this is just show some of the details of the gels that we have. Okay, and also and there's also a bit of the experience that I'd like to share with you is that a lot of times it's not just the gels that changes the result of your the final separation of your protein. It's also the sample buffers, regardless what kind of gels you use, and it's always a good idea to use a good sample buffer. So here we compare the typical lamellite buffer with the LDS buffer that we have and we use in our labs all the time. And we run a lysate process with these buffers, and when you enlarge on the on this section, and if you look at the separation, you can see on the LDS buffer, even though you run it on the same SurePaid gels, you have a much better separation with the LDS buffer compared to the lamellite buffer. So if you have not tried it before, try it and see for yourself. Now with the precast gels, we can cut the separation time to about half an hour. Now we sum everything together, it just seems like we were able to get the whole process done in about, let's say, 3 hours. That's a much, I would say that's a much welcome, improvement from the 10 hours we used to have to spend in the lab. Okay. So just before we finish our topic today, I think I'd like to bring in the eStand as well, not just because it's a device that we offer, it's also an application that we recently developed. So as you probably know, eStand is a device to stain gels using a blue dye, and that's similar to Comasi stain, but with a better sensitivity. Now it looks similar to EBlock, and it's under somewhat similar principle. So the goal is to shorten the staining, gel staining time. Usually it's 3 to 6 hours. And now we can do it in about 10 minutes, but that's not the main point here. So here shows some of the stain results. You can get very good and even stain across the board. So recently we have developed a protocol which is available for free on our website, where you can go just search for eStand L1, and you can find the protocol on your right-hand side as a link. It's a PDF file. You can download it. And so in this protocol, we use the pencil stand to stain membranes for sometimes the total protein normalization process. So you can use this to stain the membranes very quickly and get a very sharp stain, and you can use that to quantize the total protein of your gel if you need to use the total protein normalization for your Western blot. So yeah, just a bit of a tidbit here. Now, back to a bit of a summary for today's talk, and after a few years of work, we were able to make 3-hour Western a reality. Okay, this doesn't come in one go. We have put our efforts into multiple devices and consumables to be able to do that. So that's what we covered today here. That's EasyOS Lite, which is what we just launched, a fully automated Western incubation device. The EBlock L1, the only fast wet transfer device that you will find, and then also our very good quality short page precast gels. And bring these together, that will be able to get your Western process down to about 3 hours, and from the 10 hours we used to have to spend. So with that, I will conclude my talk today, and I thank you for attending this webinar, and I really appreciate your time. And now I open up the floor for any questions you might have. And Cassie, if you read it to me, and I can answer it online.
Definitely. So thanks, Dr. John, for the presentation. We'll go through the questions from the floor right now. So the first question, depending on the protein size, what is the average time for eBlock to perform the transfer?
For eBlock, usually it'll take about 12 minutes, I'd say. Our experience tells us about 12 minutes would be able to work for most of the size of proteins. For a larger protein, something that's around like 200 kD, that you might need a bit of optimization, but usually for a typical protein, somewhere around 100 or 40 kD, 12 minutes is more than enough.
I see. Okay. The next question, does your system accept non-precast gel? Yeah, it does work. Sometimes depending on the quality of the gels. When you say system, I'm not sure which system you mean. If it's eStand, yes, it does accept homemade gels. As to eBlock, it does as well. For some gels, because of the polymerization is not very complete sometimes in the homemade gels. When you transfer in the eBlock, if you use a very fast speed, the gels might get a little bit mushy, but you'll still get your transfer done. So that's okay. Yeah. Okay, thanks, Dr. John. There's a few questions from one attendee, so we'll take it one by one. The first question, is it correct that the instrument only takes 2 hours in total from blocking to secondary antibody incubation? This is referring to the EasyOS instrument.
Well, I would say it depends. I would have to qualify this. And because EasyOS is a device that's open to different protocols, that really is depend on the protocol you use. Now, the 2 hours I was mentioning is more about if we combine it with the EasyOS diluent. Right now, if we use a standard protocol, it'll still take whatever time you use to do it. I think the advantage of using it is that you'll be able to walk away. You do not have to safeguard it, and then you do not have to worry about going back every 5 minutes to change a buffer.
So, but once we have the EasyOS diluent, then you will be able to further cut down the time. So, hope that I made that clear. Yeah.
Okay, thanks, Dr. John. The next question: how many gels or membranes can be transferred at a time? This is also for EasyOS.
If we talk about transfer, I think it might be EBlock then, because EBlock is the transfer device. So for EBlock, the cassette size can fit. So there are actually 2 cassettes on each device. They're independent to each other, and so that you can transfer 2 gels at the same time. And they can be transferred, at different pace if you like. So.
Okay. The next question: can the EasyOS instrument, process with more than 1 primary antibody at a time?
Right now, no. For each run, you use 1 set of antibodies, 1 primary and 1 secondary. We're working on a pro version of the device, which will give you that capability, where currently we're looking at something like, 4 primary antibodies and I think 2 or 3 secondary antibodies. And that's coming soon. But in this EasyOS Lite device, it's 1 set of antibodies.
Okay, thanks, Dr. John. The next question is regarding to the eStand system. So which types of protein gels are eStand protein staining system compatible with?
So I think the most of our tests are done with the SurePage gels. So I would say SurePage gels will work the best. And we had experience with our customers who has used other gels on the system as well. They work just fine. But our experience is that, seems to, confirm that, most gels will stand well on the eStand device.
Okay, thanks, Dr. John. So another question: what about cross-contamination issues in the EasyOS instrument due to residue of buffers remaining from the buffers that used earlier?
Okay, I see. So we have looked at that very carefully. So there are a couple ways to basically avoid that. And so the first is that after each protocol, we have a washing process where the system will be completely washed and all the antibody will be removed from the system. And after a number of uses, let's say if you've used it for a month or for 20 membranes, then it's also there's also a protocol where you can deep clean your device using more, more stronger cleaning solutions to further remove all the residues of from all the components in the solutions, like milk and any kind of protein residues that's in the system. So in our test, we do not see contaminations when we are testing for it. So.
Okay, thanks, Dr. John. So the next question: how specific is the antibody recovery from EasyOS, and also how pure will that be?
Since each of the incubation is done separately, and when it's recovered, it's just going to be similar to the solution that you put into the system. Of course, because there might be residual washing buffer from the steps before, you might get a slightly larger volume, a little bit of dilution, but that's usually not a concern. Yeah.
Okay, thanks, Dr. John. So the next question: for EasyOS, how many membranes can be processed at a time?
2 membranes. 1 set of antibodies and 2 membranes, and the membranes can be set face to face with a spacer in the middle, or actually 2 spacers, one on top, one on the bottom, to keep them from floating, and they can be processed at the same time. We've tested it and it works well.
Okay, thanks, Dr. John. The next question: Can a Western blot be performed on a gel that has been stained with eStand protein staining system?
We've not tried that. I would say that's probably okay, but usually it's not recommended. I would say if you want to do this, you want to stain the gel and also look at the Western blot, I would run 2 gels with the Sure page and side by side, and they should have the same sample loaded on them. And one I would use for protein, the gel staining, and the other one I would use for Western blotting. And that should give you a much better and more reliable results. And that'll be my recommendations.
Okay, thanks, Dr. John. We'll take on the last question from the floor. So the last question: Can I blot very thin or very thick gel using the EBlock protein transfer system?
Sorry, can you repeat that? It was breaking up a bit.
Yeah, sure, no problem. So can I blot a very thin or a very thick gel using the EBlock protein transfer system?
A very thick gel, I see. Yes, the answer would be yes, you can. However, the condition might need to be tweaked a bit. And also, because the gel is thick, you're looking for good transfer. It might take a bit longer, and also the voltage we use might need to be slightly different. So the condition might need to be tweaked a bit, but I believe it'll work just fine. If you have a specific depth, could let us know, then we can look into our data set and to see if we have tried anything similar to it. And just reach out to us offline, and we'll be able to help you. Thank you.
Okay, thanks. There's one more question that came in just now. Maybe we'll just take this one last question.
Sure, yeah.
Okay, so can we use our lab-made staining and destaining solution, and how do we optimize the eStand system?
Do you mean use the homemade solutions instead of the eStand solutions?
Yeah.
There's a specific recipe. I understand, yes. You can make that solution yourself if you would like to, and I think that's possible. But it might, sometimes it might vary a bit, because when you make the solution, if it's not made in a factory, the consistency might not be as good. So you might have slightly different results, if you use your own solution, but you can. That'd be my answer. So yes, you can use the solution. You might get inconsistency once for a while. That's usually because in the lab, different people are making the solution, and then many people are using the solution. So you might, get, here and there some inconsistencies. Okay.
Okay. All right. Thanks, Dr. John. So due to time constraint, we'll just end the Q&A session here. So for those questions that we didn't get to answer just now, I'll email back the answers to you. So thank you once again, Dr. John, for the great presentation, and to all of us who joined us today. And so sorry about the technical issue just now. Thanks, everyone.
Thank you.